Laboratory preparation of what? Acid. Now, in case you're asked laboratory preparation, short way to know that. First is dissolution, simply dissolution of acid anhydride, dissolution of acid anhydride in what? In water. But some students find it difficult to articulate this expression, dissolution of acid anhydride in water. But a very simple way to do that is, now first is, what is acid anhydride? Acid anhydride simply means non-metallic oxide that dissolves in water to form aqueous solution whose pH is less than 7. You will all agree that a pH equal to 7 is neutral, pH greater than 7 is alkaline, pH less than 7 is acidic. Therefore, acid anhydride are what? Non-metallic what? Oxide. So, in a case, in any event where you find this expression difficult to articulate, all you need to say is dissolving or adding non-metallic oxide. Adding non-metallic oxide to what? To water. This is as well admissible in chemistry. So, dissolution of acid anhydride in water, or for students who might find it somehow ambiguous or complicated to rattle off, you just say adding non-metallic oxide in what? Adding non-metallic oxide to water. Very simple, without talking too much. This is carbon 4 oxide dissolving in water to give you trioxocarbonate 4 acid, HCO3 aqueous. Then we have it to be SO2. SO2 dissolving in water to give you H2SO3, sulfurous acid or thiosulfate 5 acid. Then we have SO3, sulfur 6 acid and sulfur 6 oxide dissolving in water to give you H2SO4, sulfuric acid or tetraoxosulfate 6 acid. However, we have what is known as mixed acid anhydride. What is meant by mixed acid anhydride? Look at the word mixed, which means it is a synthesis of two substances. So mixed acid anhydride is one that dissolves in water to give a mixture of two different acids, as typically exemplified by nitrogen dioxide, or are you backing nitrogen 4 oxide, NO2 plus H2O. Now this is supposed to give us just HNO3. Look at this. Take this oxygen, add it to this. We are left with 1 hydrogen. So the remaining hydrogen, this is the 1 hydrogen. Remember there are 2 hydrogens. So 1 hydrogen. Add this oxygen to this to give you NO what? NO3. Then the remaining hydrogen pair with just nitrogen dioxide to give you HNO2. As you can see, the equation is balanced. Now I put a 2 here. Put a 2 in front of NO2. So 2 here, 1, 1, adding up to 2. This is 4 plus 1, 5. 3, 2, 5. 1, 1, add up to 2. And here is 2. Therefore, NO2 is an archetype or a typical example of mixed acid anhydride, as evident on the equation of reaction. 2 different acids, trioxonitrate 5 acid and dioxonitrate 3 acid, NO2. Now, that is the first method, adding non-metallic oxide to water. Then the second one is direct fusion of constituent elements. Now, some students may find this difficult to rattle off. This second mode of preparation is peculiar to hydrogen halide acid. So you can say direct combination or direct synthesis. That's another word you can use. Synthesis means combination or joining together or fusion of 2 or more substances. So direct fusion of constituent elements or direct combination or synthesis of hydrogen and what? A halogen. A hydrogen and a what? A halogen. So in that, hydrogen, dry hydrogen, when heated with chlorine gas, yields hydrogen chloride gas, which is then dissolved in what? In water to give hydrochloric acid. You can see this is a hydrogen halide acid. Then the second example, hydrogen gas combines with bromine when passed through electrically heated platinum spiral to yield hydrogen bromide gas. which in turn is dissolved in water to furnish hydrobromic acid. Finally, a mixture of hydrogen gas and iodine is heated in the presence of platinum as a suitable catalyst to yield hydrogen iodide, which ultimately is dissolved in water to liberate hydroiodic acid. So this second mode of preparation is technically relevant to hydrogen halide acid. So you can articulate the expression in two ways: direct fusion of constant elements, or direct combination or synthesis. Direct combination or synthesis of hydrogen and a halogen. Then the third method is displacement. I'll give you an abridged form of the statement, an abridged version of the statement. Displacement of more volatile, in parentheses. When I say parentheses, in the bracket, more volatile, that is weaker acid, from its solution by a less volatile or stronger acid. Displacement of more volatile or weaker acid, more volatile or weaker acid from its solution by a less volatile or stronger acid. For example, tetraoxosulfuric acid displaces the more volatile or weaker acid, trioxocarbonate 4 acid, from aqueous solution of sodium triiosocarbonate 4. Here, as exemplified in the equation of reaction below, H2SO4 plus sodium triiosocarbonate 4. This will give you this and this. This will give you sodium tetraoxosulfate 6, then water and carbon 4 oxide. The carbon 4 oxide is retrieved and dissolved in water to give trioxocarbonate 4 acid. Then the other one is tetraoxosulfate 6 acid displaces the more volatile or weaker acid, which is HNO3 sodium nitrate. This will give you H2 This will give you HNO3 and sodium tetraoxosulfate 6. Sodium tetraoxosulfate 6. 2, this is 1, this is 1. So if you look at here, tetraoxosulfuric acid displaces HNO3 from aqueous solution of its of its salt. These are the three modes of bearing acid. Then we'll look at the physical properties of acid. Physical. What are the physical properties of acid? 1. Aqueous solution of acid have pH less than 7. Aqueous solutions of acid have pH less than 7. 2. The concentrated form of acid, such as tetraoxosulfate 6 acid, perchloric acid, pernitric acid, nitric acid, etc., are potentially corrosive. Then 3. Acid turns blue litmus red. Acid turns blue litmus red. The presence of acid in unripe fruit accounts for the characteristic sharp sour taste associated with the fruit. Then that's the four physical properties of acid. Number 1, presence of acid in unripe fruit account for the characteristic sharp sour taste. 2, aqueous solution of acid at pH less than 7, and acid turns blue litmus red. Concentrated form of acid such as H2SO4, HNO3, HNO4 is potentially corrosive. Then the next one is chemical properties. Under the chemical properties, we examine just 2 features. Chemical properties of acids. Number 1 is action of metals. Metals that are strongly electropositive, that is, metals above hydrogen in the standard reduction potential series, otherwise called electrochemical series, could displace hydrogen and liberate it as gas. So this is HCl plus sodium, giving you sodium chloride, and hydrogen is displaced and liberated as a gas. Then, however, note that HNO3 combines with metal to liberate nitrogen 4 oxide gas instead of hydrogen gas. This is because trioxynitrate 5 acid, old name nitric acid, is a potent or powerful oxidizing agent. As a consequence, the atomic hydrogen that is liberated is further oxidized by it to water instead of what? Instead of hydrogen gas, as exemplified in this equation. HNO3 plus magnesium. This will give you magnesium trioxynitrate 5 plus nitrogen dioxide or nitrogen dioxide plus water. So you can see that HNO3 is at variance with the fact that acid combined with metals to form salts and effervescence due to evolution of what? Hydrogen gas. So if you look at HNO3, it combines with magnesium. Instead of giving hydrogen, it yielded water, which implied that the hydrogen was further oxidized to water. So that means, in general, HNO3 is a powerful oxidizing agent relative to other strong acids. Second chemical property is number 2, action with what? Action with alkali. The reaction involving a hydrogen ion from an acid and a hydroxide ion from an alkaline to form water as the only product is regarded as neutralization reaction. So acid combines with alkaline to form salt and water. So HCl plus sodium hydroxide giving you sodium chloride and what? And water. So there, this is a salt and this is water. If you write this reaction ionically, water is cancelled, which is indicative of the fact that sodium ion and chloride ion here are called spectator ions, which means that they do not really participate in the reaction. The major active ingredients that participate in these reactions are hydrogen ion and hydroxide ion respectively. Therefore, it is more congruous or appropriate to define neutralization reaction as the reaction between hydrogen ion from an acid and hydroxide ion from an alkaline to furnish water as the product. So that is neutralization reaction, and acid combines with alkaline to form salt and water. Then finally, we'll talk about the uses of acid. What are the uses of acid? Acid are used in refining, e.g. sulfuric acid, iupacnate, tetraoxosulfate 6 acid. They are as well used in manufacture of explosives such as dynamite, TNT, dynamite, and fireworks as well. Examples of acid used in that, HNO3 and picric acid. Then they are also used in mercerizing cotton. Acid are used in mercerizing cotton. Some are used in the manufacture or development of drugs and important chemicals. Some are also used as well as reagents in the laboratory. Example, trioxynitrate 5 acid, old name nitric acid.